question, I think. No. More up. Up.
This mass by meter.
No. More up. We were in one question. I think I'll tell you. Yeah, one more page up. Yes, this question you are doing last. You have
I
to start
think
from this one.
what I think is we did till this point. I was giving you some examples, like if you
Yeah,
have
you
We
are
we
doing
did
this.
this, but we did not do the other page, the previous one before it. Yeah, there are three types of terms. This one we did not do.
this one.
Yeah.
Actually, we did this as well. Like, do you remember I told you, like, if you are talking about one atom, you will call it in AMU. If you are
Oh
talking about
yes, yes, yes,
one mole
yes,
of
yes,
atom, you will
yes.
take it in grams, right?
But can you
That's
repeat once again?
yeah, sure.
Okay.
See, what is atomic mass? Atomic mass is the mass of one atom, right?
Yes.
And what is molecular mass? It is a mass of one molecule.
One
If you are
molecule.
using a atom or a molecule, you will weigh it in AMU.
AMU.
But whenever you are using this molar term, this molar
Mhm.
terms means what? It means you are talking about 1 mole of particle.
One molar particle.
And when you are
Point of
using 1 mole, you can use this gram term. You will be using gram.
Yes.
If I am saying 4 gram of helium, that means I am not just talking about one single atom of helium. I am talking about billions of helium atom, right?
Yes.
Okay, so this was a simple question. What we have here? We have a 2.3 grams of sodium wire, and you need to tell how many atoms are going to be there. So you can just simply convert it into number of moles. And if you know how
yes.
many moles are there, you can simply tell the number of atoms as well.
Yes.
Okay. And yeah, relationship between STP and NTP. I have told you that
Yeah, this one is.
if you have a gas at STP,
Mhm.
then what? Then you will have the volume fixed. It will occupy 22.4 liter of volume, right? And we can
Yes.
derive a different formula from here as well to calculate
24.4.
number of moles. If you have given
Yes.
volume, you will divide it by molar volume. So you can also convert it into moles. Yeah.
Yes.
Okay, let us move ahead. This is percentage composition. This is simple percentage formula. Pure marks divided by total marks. So if you're talking about sodium, put the sodium here and divide by total molecules mass
Yes.
multiplied by 100.
By molar mass.
Molar mass, right?
Yes.
Okay.
Yes.
Yes.
And
And
this,
I think you gave the homework. I did that one, but in that empirical formula was there, so I left that one.
okay, no issues, no issues. What was the homework that I gave you? Acha, in the assignment.
Yeah, assignment. Yeah.
Yes.
Mm.
Okay, have you uploaded your PDFs?
Yeah. I've uploaded.
Yes.
Okay. I will check.
Okay.
So this is concentration. Why we studied mole concept? Because we need to apply it in concentration term. Mole concept is very important if you need to understand the concentration of a solution. I have told you that qualitatively you can easily tell like something is little bit sour, little bit salty, little bit sweet. But if you have to measure it in exact data, you will need some concentration term like molarity and molarity if you need to perform some experiments, right? So for that, you need to understand the mole concept, and we already did that. So now we will talk about different type of mole fraction. And before it, how you can express concentration of a solution. The amount of solute dissolved per unit amount of solvent or solution is called strength of a solution. Suppose if you have a glass of water with let us say 10 ml 10 ml water, and you have transferred so much amount of like बहुत सारा sugar, so that solution will be concentrated. So the amount of
Mm.
solute is going to decide how concentrated your solution is going to be. If the solute is more concentrated, if solute is less, it is less concentrated. So for this, we have several types of concentration terms that we can use to understand the mole fraction. Oh, sorry, concentration term. The first one is mole fraction. I have told you what is
Yes.
mole fraction in the last class. Can any one of you tell me or explain what is mole fraction? What you have understand? What you have understood?
Like here, if there are three terms, A, B, C, so if you have to find the mole fraction of like a term, so we have
Hmm.
to divide it by mole of A by total mole. total
Yes.
number of moles. So then we have to add everything that like mole of A, B, C, and then we'll get the answer.
Yes. And what is one important property of mole fraction? That the sum of all the species is always going to be equal to.
Equal to 1,
This
yeah.
one.
And if for this formula is only used for finding first one. Second one we can find with this one, A plus B, like this, A plus B plus C is equal to 1, like that we can find.
See, you said for the later one, the shortcut is this, but you can
Yeah,
also find that with the help of this
yeah,
formula.
but it will take a lot of more time
Yes,
than this
yes,
one.
okay, good. And the simple formula is moles of solid divided by total number of moles in solution, right?
Mhm.
And we
Yes.
also
Yes.
talked about mass by percent. Can you tell me what is mass by percent?
Mass of solution.
Whenever you are seeing this term, that one thing for sure that you can understand is the solution amount is always going to be 100 gram. Whenever you are observing this weight by weight or mass by mass percent, then your solution is fixed. Suppose I am saying 20% weight by weight NaCl solution. That means your 20 gram of NaCl is present in 100 gram of solution.
Okay.
And if the solvent is not mentioned, you will take it as water. Now, if you know solution and you know the solute, you can also calculate what? Solvent.
Solvent, yes.
You will simply
Yes.
divide, subtract 100 by 20, and this is your answer, like 20 plus 80 is equal to 100 gram. Simple.
Yes.
So the formula is mass of solute divided by mass of solution into 100. It is again unitless because you are dividing gram by gram, and it is going to give you 1.
Yes.
Any doubts?
No.
No.
We have to start from here in today's class, right?
Yeah, I think so. Volume by
Yes.
percentage,
Now,
yes.
volume by volume is very similar if you compare it with mass by mass. If you are seeing volume by volume, your solution is again fixed. But as we
Mm.
are talking in terms of volume, we are not going to use gram. We are going to use milliliter because
Mhm.
volume is measured in milliliter or liter, right? Here we are going to use milliliter, 100 milliliter. If I'm saying 10% ethanol volume by volume solution, that means 10 ml ethanol is present in 100 ml of solution, right?
Yes.
So
Now what?
100 ml of solution means 90 gram water.
There
90
is
ml.
the like, no, there is the actual issue. There is the
20
actual
ml.
point. Let me come
Yeah.
to that point. See, have you heard? See, what we have heard from the junior classes that mass is conserved, right?
Yes.
What
Yes.
Abdullah said, if your 10 ml ethanol is solute and 100 ml of, let us say, the solution is 100 ml, the
Yes.
difference 90 ml is going to be your solvent.
Yes.
If you go by simple methodology, you can say this, but is it correct or not? Let us try to understand it. Suppose mass is conserved that we have studied so far. If you are adding 10 gram to 90 gram, then you will get 100 gram because mass is conserved, right?
Yes.
Yes.
But have you ever heard volume being conserved? No, volume is not conserved. If you are adding 10 ml to 90 ml, it is not mandatory. You will get 100 ml of solution because while you are talking about solutions in like volume, when you are basically talking about volume, the overall mixture's volume will depend on the type of interactive forces it has. Okay, to put it
Ah.
simply, to put it
Mhm.
simply, uh, volume is not conserved. First point is this, and volume is not an additive property. If you are adding 10 plus 90, that then it is not mandatory for
100.
your, you will get 100. Why? Because you have different type of attractive forces inside your solution, and this we are going to study in your 12th class. We have a different law, we call it Rawls law, and there we will understand how different solution have different attractive forces. For now, what you can understand, that if you have 10 ml solute and 100 ml solution, then you cannot say that your solvent is going to be 90. It will depend. Okay, is it clear what we cannot say here? You cannot tell the exact amount of solvent if you are talking about solution. Why? Because volume is not conserved. Any doubts what I
Yes.
said?
No, no, no.
So what I have written here, hence we cannot say that the solvent is going to be exactly 90. It could be less or more. It could be 90.2, 90.5, or 89.5 or 89, depending on the attractive forces. Unless the solution is ideal solution. Suppose in the question, if they have written your solution is ideal solution. Then you can say that the amount of solvent is going to be
Okay, okay.
exactly 90.
Okay.
Okay, but if they
Yes.
have not set this ideal condition, then you cannot predict the amount of solvent.
Okay.
Okay, now the
Yes.
question is, if you are not able to understand, if you are not able to say the amount of solvent by simple way, then how you can measure the amount of solvent? Because to perform experiment, you should be able to calculate the amount of solvent, right? So for solution, if you need to know the amount of solvent, what you are going to do basically, you will take a beaker. You might have seen that there is some marks like 100 ml, 50
Yeah.
ml, 300 ml. So to calculate or measure the amount of solvent, what you are going to do, you will simply put your 10 ml ethanol, right?
Yes.
And you will fill water till 100 mark. This 100 ml mark that you have, you will fill water till
Yes.
that point, and
Yes.
you will see whether you are getting exactly 90. It could be 89.5, it could be 89, it could be 91.5, it can be 91, right? You will have to perform experiment to actually calculate the amount of solvent. You have to fill it in the beaker, right?
So how to find the solvent?
Solvent, yes.
Suppose suppose you have a pipette, right?
Yes.
Let us say uh, you are not able to say it is going to be exactly 90, but you know it is going to be near 90, right? So
Yeah.
we will see, you can take measuring cylinder, you will measure it till, let us say 80, you will transfer it, then you will drop wise add it, you will see like you have let me draw it. Have you seen this measuring cylinder?
Yes.
Has marks
Yes.
like this. So
Yes.
Yes,
what you
yes.
will do, you will take 90 ml and you will transfer it in this. And what you will see that if you are getting exactly 90, then your solvent is 90. But if you are transferring 90.1, or let us say 91, that you can say that the solvent is not exactly 90, it is 91. And if you are transferring 89,
So
you will,
here solvent is water, right?
yes,
Okay.
whenever solvent is not mentioned, you will take it as water.
Okay.
Okay.
So the formula is again same, volume of solute divided by volume of solution into 100.
Okay.
Okay. The upper thing is solute, the denominator is solution, and you will have to multiply it by 100.
Okay.
Now, what we are doing in next step, we are mixing gram in ml. Now your solute is in gram, it is a solid thing, and your solution is in ml. If you're talking about glucose in water, how you can understand it? Your glucose is in grams and your water is in solution, like ml.
Mm.
So if I am saying 10% mass by volume glucose, what I can understand, 10 gram of glucose is present in 100 ml of solution. Again,
Okay.
I cannot predict the exact amount of solvent, because whenever you have to add two things, whenever you have to add two things, the units of those two species should be same. You can
Same.
only add gram to gram, ml to ml, right? So here, because your solute is in gram and solvent is in ml, if you
Mm.
are adding these two things up, you are going to get 100, but you cannot add them because of different units. So again, here as well, you cannot predict the exact amount of solvent.
So we cannot add this one
By how you can add this? Suppose you are adding
by
gram in
converting
ml.
something.
For this, you need density formula. Suppose density, right? Density is mass per unit volume.
Yeah.
So you need to convert this into gram. Then you can add it up. You
Mm.
have to multiply
So,
this volume by density. If you are multiplying this volume by density, then you will get it in grams. Then you can add it up. But in this state, you cannot add this up.
then we will get 100 a gram
Uh,
if we convert and add.
if you convert and add, you will get some grams. That will depend on the value. Suppose the density is, it will depend on the density.
Density is equal to mass by volume.
Density is equal to mass by volume, right?
So 10
And
by
here you have value.
so
Sorry,
10 by 90.
10 by 90. Let's see. Here they have given you the volume, and
Yes.
you want to know the density. Sorry, the
Yes.
mass in grams.
Yes.
So to convert it into mass, that means gram, you have to multiply it by density.
Mm.
And you need to know the density. It will depend on the
Mm.
what the type of solvent that you are using. Let us say
Solution.
Yes.
if I'm talking about water, the pure water's density is 1.
Yes.
So the mass is also going to be 90 gram. So if both of these things is in gram, then you can add them up and you will say that your solvent is 90. But here at this stage, you cannot add this up. So you cannot predict the exact amount of water.
So simply we'll write like this. 10
Simply,
gram. Yes.
this is not possible.
Mm.
90 ml of water, it is not possible because these two are in different units.
But if we calculate here density of water, we will not get 1, right? We'll get 1 by 9.
Not 1 by 9. Density of water. Okay. 1 by mass by volume.
Yes. Mass is 10.
Mass, how mass is 10? You are talking about this one?
Yeah.
Okay, mass is 10, okay.
And 90 is the volume.
No, you are talking about glucose mass. So you have to take the glucose volume as well. This is water's volume. You cannot put 90 here.
Okay.
To
So
put
whose
it
volume we
simply,
have to put?
if you need to calculate the density of glucose, you should know the volume of glucose as well. Then you will be only able to tell.
Okay.
So see, I think you are getting confused. Let me do it again. Just give me a second. This is not the case. Why? Because you cannot add something which have different units. You cannot make a solution of 100 if you are adding 10 gram to 90 ml because gram and ml cannot add up. Is it clear?
Yes.
So what we have studied so far, that only when you have weight by weight percentage, then only you can predict the amount of solute. But if you have volume by volume or mass by volume, you are not able to predict the mass of or volume of your solvent.
Okay. Okay.
This is a very simple question and we did this in the last class as well. Can
Yeah.
you tell me what is happening?
Here we have to calculate the mass percentage of benzene and carbon. And they're telling it there is 22 gram of C6H6 and it is
Mhm,
dissolved in 122 gram of CCl4.
mhm. So they are
So
basically asking you about the percentage of benzene.
yeah,
Yes.
and yes.
So you know the formula,
So
mass of solute
yeah,
divided by
so
mass
we
of
have to do
solution.
it 22 divided by 1 by 22 into 100.
into 100.
1 by 122.
Yeah, one no
22 by 122
22
into
by
100.
122 into 100.
Galat. This is solvent. In the denominator, you have to put solution. Solvent plus solute is solution.
Oh,
So
so
yeah, so we have to add
32
144
by
22
144
by
into 100. Okay.
Yes.
yes, yes,
Total is
This-
solution.
Okay.
Okay.
If you have any doubt, okay, let me know.
okay. No.
Pakka, Kamran.
Yes.
Yes.
Now we have another concentration term. This is called parts per million. Okay. Again, you are trying to calculate the concentration or strength of the solution. Here, how parts per million is different from the things that we have studied. In parts per million, you are using to calculate a very small amount of solute. Suppose parts per million ppm is generally used when we are dealing with contamination. Okay, suppose your water tank is contaminated by some foreign entity, right? Suppose CHCl2 chloroform, it is contaminated by chloroform. So even very small amount of chloroform can harm you, right? So whenever your solute is in very small amount, you generally use the concentration term. We call it ppm, parts per million. What is parts per million? Can you tell me what is million? 1 million is basically 10 to the power 6,
Yes.
right? So the
Yes.
ppm formula
And
is
yes.
particle of solute divided by particle of solution into 10 to the power 6.
Okay.
What we are doing, basically we are putting solute in numerator and solution in denominator, and we are multiplying it by 10 to the power 6 because we are talking about million, right?
Yes.
What is special about parts per million? It is not just specified or specific for mass or volume. It can be applied for either one of them. You can take gram, you can take ml, but the thing is, if you are talking about if you are taking solute in grams, you have to take solution in gram as well. If you are taking solute in ml, you have to take solution in ml as well. But you can apply it to both. mass as well as volume.
Hmm.
Okay.
Oh,
ppm can be measured for particle mass or volume.
So this particle of solute will be given in the question.
Yes, they will give you this. I have a question just after this line.
Okay.
Okay, let us say I have specified. I'm saying that the entire thing that we are doing is in grams.
Hmm.
Okay, so I
yes.
can write it like this: mass of solute divided by mass of solution into 10 to the power 6.
Hmm.
It is ppm, right?
Yes.
Yes.
Can I write 10 to the power 6 like this?
Yeah, you can.
Base 10
Yes.
power n. If I am doing this,
We can write it 10 to the power 3 into 3.
we can also write it, but that is not going to help us in any way. But if I'm writing
Okay.
it in this specific way, what I'm saying, if I look this carefully, then this is nothing but mass by mass percentage, mass of solute divided by mass of solution into 100.
Oh, yes.
Oh yeah. Hmm.
Okay, so there is a relationship between ppm and mass by mass percentage, and that you can see ppm is nothing but mass by mass percentage into 10 to the power 4 if you are talking in terms of grams.
Grams. Okay.
Okay.
So
Okay,
same for we can write for volume by volume also.
volume by volume you can also write, but
Yes.
there you have to use ml.
Yeah.
Okay,
If it is in grams, so we have to use mass by mass. If in ml, so volume by volume.
yes, that is the thing, right?
Okay. Okay.
Now, suppose if I'm saying you have a 4 ppm solution, what does it mean? Suppose I'm saying that Kamran has 4 ppm solution. What data you can interpret from this small line? If you are saying 4 ppm solution, that means in your solution you have 4 gram of solute in 10 to the power 6 gram of solution. If you compare your solute with solution, is it not very small? 4 grams with respect
Yes,
to a
very small.
million is very small. So where you are
Very
going
Yes.
to see ppm when your solute amount is very small. So if I'm saying
Oh,
4 ppm of solution, it means 4 gram of solute present in 10 to the power 6 gram of solution.
small. Yes.
By just this small data, you know the amount of solute as well as the
Hmm.
amount of solution, right?
Hmm.
yes.
So if you understand this, then I would request you to solve this question. Let me give you some hints. You have a sample of drinking water. Okay.
Yes.
It was found to be contaminated by chloroform.
Mm.
The level of contamination is 15 ppm. By mass, if they are putting by mass, then you have to take everything in gram.
Gram. Okay.
You have to convert this into mass by mass percent. So what you can do with this small
Mm.
data, you know the amount of solute as well as amount of
Salute.
solution.
Yes.
So in mass by mass percentage formula, what data you need? You need mass of solute divided by mass of solution into 100.
Yes.
So I have told you the answer as well. So tell me the exact value that you are getting. Just solve it. Very easy question.
Is it 15%?
Yes, 15.
Okay, let's see if it's 15. It is 15.10 to the 15 to 10 to the power minus 4 or 1.5 into 10 to the power minus 3. See what mistake you made. This is giving you the data about solute and solution. And
Yes.
you was asked to calculate weight by weight percent of CaCl3. So the formula is
Yes.
mass of solute divided by mass of solution. Mass of solute is 15, mass of solution 10 to the power 6, and you have to multiply it by
Yes.
100 because you are talking about weight by weight percentage.
Okay.
What you did? How you were getting 15?
I think instead of CHCl3, I thought that the solution, so I took the 15 there.
See, 15, you are supposed to get 15 because
No,
the
I
mass of
mean, I
solute.
took 10 to the power 6 there.
Okay,
I
here 10 to
mean,
the power 6.
yeah, here I took 10 to the power 6.
No, because you are supposed to answer in terms of weight by weight percent. In weight by weight percent formula, this is the formula mass of solute divided by mass of solution into 100.
But there is 10 power 4 also no, in the formula. Into
Uh,
10 power 4.
the relation formula,
Yes.
Relation, that is relation, no.
see mass of solute, let me do it that way as well. Weight by weight percent into 10 to the power 4. You are telling this now? Talking about
Yes.
this one. So if we do this, mm, 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 see, if you expand it, weight of solute divided by weight of solution into 10 to the power 2 into 10 to the power 4, it is again going to become 10 to the power 6.
Yes.
You just
Oh,
have to expand it.
okay.
Is it clear how we are supposed
Yes.
to do it?
Yes.
Okay, for
But
this
why
one,
here you took 100? I have one doubt here. 100, why you took?
see, the question is in terms of weight by weight percent. Okay, the
Okay.
formula for weight by weight percent that we have studied is this. This is the
Uh,
formula.
Oh,
We are
okay.
oh,
talking in terms of percentage.
that is not PPT, the one
No,
we are finding.
they have given you ppm. You have to use
Yeah.
the data to convert it into mass by mass percent. See, read the question.
Uh, okay, okay. Mhm.
Express this in mass by percent.
Okay, okay.
Any doubts?
If they asked in ppm, then it means you have to do it with 10 to the power 6.
Yes, but here they have already given you ppm, so you don't
Okay,
have to.
okay.
Oh,
Okay. For this question, first we need to talk about molality and we'll come back to it. Now parts per billion, everything is same. Just what you have to do, you have to replace 10
10
to the
power
power 6
9.
by 10 to the power 9.
Uh,
Everything is same.
Okay.
Suppose
okay.
if I'm saying 15 ppb solution, that means 15 gram of solute in 10 to the power 9 gram of solution.
Okay.
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 Yes.
Now molarity and molality, very famous topic. Let us talk about them. So what is molarity? Molarity is first of all uh, denoted by capital M. Whenever you are seeing molality, you will see capital M. What is molarity? Molarity is nothing but mole of solute divided by volume of solution in liter. What is mole of solute? Mole of solute is basically number of moles of solute, right? You can write it like n
Yes.
solute, and volume of solution in liter. Okay, what other ways do we have to expand this number of moles? We can write it like given mass upon molar mass and given number upon Avogadro number, right?
Yes.
This is to find this one moles, number of moles.
You have to find number of moles, you will see the volume and you will put the data and you will
Yes.
get molarity.
Okay.
If you have to calculate, if you have to tell the units of molarity, it will be mole because mole per liter.
So it will be more L minus 1.
Mole per liter, mole L minus 1. Okay?
Yes.
It is temperature dependent. How? Let us talk about it. Suppose while we are doing experiments in terms of volume, let us say like a milliliter liter, we have a volume, right? And what we have studied that suppose you have some water inside a beaker, right? And if you are heating
Yes.
it, what you will observe? The volume is going to change. Some of it might evaporate, right?
Evaporate.
Yeah.
Yes.
If you start with 10 liter, after some time it will be 8 or 7 liter because volume
Decreases.
Yes.
decrease, right? So volume is temperature dependent. With temperature, volume changes.
Mm.
So molarity is also temperature dependent. Why it is temperature dependent? Because here we are dealing in terms
We are
of
taking volume
volume.
of solution.
Volume.
Yes.
Volume. Okay, this is the important point.
Okay.
Okay, so again, what does, suppose if I'm saying 1.7 capital M or molar, both have same meaning. We are talking about molarity. If I am talking like this, 1.7 moles of solute, okay, 1.7 M or molar, that means 1.7 moles of solute are present in 1 liter of solution. Okay,
Okay.
Yes.
Mm.
this means you have 1.7 moles of solute present in 1 liter of solution, right? This is your molarity. But what about molality? Molality, most of the part is same, but rather than using volume, you will use mass
Solvent. Acha.
and
Mhm.
solvent. Mass of solute divided by mass of solvent in kg. This is very important. In molality, you use solvent. In molarity, you use solution.
Okay.
Okay. So we measure in terms of kg.
Yes, and solvent. And
Okay.
as we know that mass is not dependent on mass is not dependent on temperature. So it is temperature independent. Molality is temperature independent, but molarity is temperature dependent because in molarity we deal with volume. Okay.
Yes.
So if they ask you a question, which of the following is temperature independent or dependent? The dependent one is molarity.
Molarity and independent is molality.
Okay.
Yes.
If they are saying 2.5 small m or molal, molal means molality, molar means molarity.
Okay.
That means 2.5 moles of solute in 1 kg of solvent, right?
Okay. Hmm.
Any doubts?
No.
No.
If here they give molar means this one. Here it will come liters, right? 1 liters of the solvent
1 liter of solution.
of solution.
Okay.
Yes. Yes.
Now, if that is clear, then do this question. 30 gram of NaH is mixed with this. Very, very easy question. You just have to put the data. Try to solve it. First of all, can you tell me what they are asking? They are asking you about, see, they
The
have written
molarity of the
molarity,
solution.
molarity. Suppose if they are not writing molarity, they are simply writing concentration. So how you would know that it is talking about molarity? By seeing this liter volume solution.
Uh,
Kamran, is it clear?
Yes.
Solve this. Are you able
Here,
to solve it?
here number of moles of the solute will be 30.
See, not 30.
It is
This
given
is
in gram. You told that molarity is measured in terms of liter.
see.
That is
This
for
is
solution.
this is the formula for number of moles. N solute divided by N, sorry, volume of
Solution
Solution.
solution
in
in liter.
liter.
Okay, number of moles. How you can calculate number of moles? You have two formulas: given mass upon molar mass
Molar.
and given number upon Avogadro number. So this is your given mass, right? You have to convert it into number of moles. So
Yes.
first you will divide. Sorry. First you will do this: given mass upon molar mass. The given mass is 30, and the molar mass you can calculate just by adding the atomic masses, 40.
Our answer is 1.5.
See, number of moles of solute, which is given mass upon molar mass divided by volume in solution, liter.
3 by
That
2.
is already given. 30 by 40
Okay.
divided by 2. This is the way that you are supposed to do it. Were you doing the same thing or some other way?
No, no. Let's see.
I
Good.
was also doing the same thing, yes.
Okay, good. Now, if this is clear, then here you have to. I am doing this because it will take time if you do it on your own. See, everything is same. The only thing that you need to uh, keep a uh, what I should say understand is this. It is asking you in terms of molality, right? And if they are talking in terms of molality, you need to take the solvent
kg.
in terms of kg, but
kg.
they have given you
Yes.
in liter.
Liter.
Well,
So first you need to convert this into kg.
hmm.
So they have given you 10 gram. You can convert it into number of moles by dividing it by molar mass. You have number of
Yes.
moles of solute. Now, if they are talking about molality, you need to understand that you have to take it in terms of liter, but they have given you in liter. So you will use this formula. Density is nothing but mass per unit volume.
Hmm.
Okay, so if you have to convert your volume into mass, you need to multiply it by
Density.
density. And
Hmm.
luckily, what we know that the density of pure water is 1. Density of
1.
pure water is 1 kg per liter. And if you are putting 1 kg per liter here and your volume is already in 1 liter, then liter will cancel out by liter. And the mass is
1
also
kg.
1
1
kg.
kg.
Is it clear?
Yes.
So you will put 1, but you have to understand the thing. Because suppose they are not giving you water, they are giving you some other solvent. So the density is not going to be 1. So your mass is going to be different.
So, do we have to learn the density of different solutions?
No, they will give you the density
Okay.
value.
Okay.
But as the density of water is 1, you should know it.
Okay.
Is it clear?
Yes.
Yes.
Okay. This is the relationship between molality and molarity. Suppose they have given you molality and they are asking you about molarity. So you can use this formula. This is molality, small m. This is molarity, capital M, right? The
Yes.
relationship is molality is equal to 1000 m divided by 1000 d in minus molecular weight of solute into molarity. You just have to learn this. Okay.
This is
If you
molar mass of solute.
This is molar mass of solute.
Okay.
Into molarity.
Suppose let us take an example. They have given you what? They have given you molarity, right?
Yes.
Yes.
They're asking you what molality. What other thing they have given you? They have given you density as well. So you can use this
Yes.
formula. See what is happening. Acetic acid. Acetic acid is this
Yes.
CH3 C double bond OH, right?
Yes.
Can you not calculate the molar mass of it? You can also calculate the molar mass of acetic acid if you know the molecular formula.
Yes.
In the formula, you need what? You need molarity, which is given
Yes.
2.05. You need density, which is given
Yes.
1.02. You need molecular mass of solute. You can calculate it, which is 60.
How
So
did you
everything,
calculate the molar mass of this CH3COH?
the molar mass of carbon is 12 plus
Yes.
Yes. Protein is
I
3.
1,
3.
The molecules
right?
are
Then you will have carbon, then you will
Yes.
2.
have oxygen, then you will add them up just.
2 oxygens, right? We have, oh, single
Ah,
bond.
here you have oxygen, right? So you will just simply
Yes.
add the atomic masses.
And what about the oxygen which is up there? Double bond O.
This one,
Yeah.
you will take it just like this. Do the calculation. I am doing it.
Plus
Plus 1. Let me do the calculation. Just give me a second.
20, 24, 24, 40, 56, 60. Yes, 60.
60,
60?
yes. Yes,
Yes.
60.
Okay, you just have to do this. Just take the individual atoms and add them up,
Okay.
right?
Yes,
Yes.
yes, yes.
So
Here,
you
while
have,
adding the molar for mass, we don't have to see single bond, double bond. It doesn't matter.
so yeah, it doesn't matter, right? And you just have to put the values and you will get your answer.
Mhm.
Simple as that. Okay. You have converted your molarity into molality.
Yes.
Okay. Now we have this another term normality, and then we'll be talking about empirical formula. Just give me 2 minutes. My laptop is going to let
Okay,
me plug in my charger. Just give me a minute.
okay.
So let us continue. We have the last concentration term, which is normality, right?
Hmm.
Yes.
And this normality is not going to appear in your exam. Like the chances are very low, but it is important if you are giving some competitive exam. So let us talk about it as well because it is very, very similar to that molarity, right? Okay. My screen is visible.
Yes, your iPad is gone.
That is one.
Screen share is gone. Yes.
Okay. Now, what is normality?
Hmm.
Normality, if we are talking about normality, what we have to keep in mind is here, rather than taking simple number of moles, we will talk about number of gram equivalent of solute. This thing is new. We have not talked about this, right?
Hmm.
We have
Hmm.
already talked about number of moles, but here we are
Yes.
talking about number of gram equivalent of solute. So
Hmm.
now, if we need to understand normality, we need to first tackle this gram equivalent thing, right?
Mm.
Yes.
So let us take this gram equivalent and study it separately. So let us talk about it. What we know that number of moles is nothing but gram given mass upon molar mass.
Yes.
So this
Yes.
number of gram equivalent is going to be given mass upon equivalent mass.
Yes.
Rather than taking given mass upon molar mass, we will take given mass upon equivalent mass. Now
Yes.
this the new term which we are dealing with is this equivalent mass. We have not talked about the equivalent mass. So let us talk about equivalent mass.
Mm.
This equivalent mass is nothing but molar mass divided by n.
Hmm.
Okay, now the actual thing that is new here is this n.
Hmm.
So now this n is what? This n is n factor. N factor is what we need to talk about it. So first, let us try to use this expanded form into our simple normality formula. Can I write normality like this? Given mass upon equivalent mass.
Yes.
Mm.
Can I write given mass upon equivalent mass into volume? Can I transfer volume here? Simple math,
Yes.
right?
Yes. Yes.
Now, what I found out that equivalent mass is nothing but molar mass upon n.
Yes.
Is what?
Equivalent mass is nothing but molar mass divided by n.
And yes.
Can I use equivalent mass as molar mass divided by n?
Yes.
Now, if you see this carefully, what is this thing? Suppose
Oh,
given mass
this
upon
is
molar mass
a
is what? Number of moles
um,
divided
number
by
of
volume.
Yes.
yes.
Which
Okay.
concentration term is this?
Molarity.
One.
Molarity. Is it not?
Yes.
Yes.
Now, can I write it like this? Molarity into n.
Ah, okay.
So normality is what? Normality is just your molarity
Molarity.
multiplied by this n factor. So ultimately what we need to understand is what is this n factor, right?
Yes.
So n factor has different meaning for different reactions. Suppose if you are talking about an acidic reaction, what is
Yes.
the main task of an acid? If you are
To
talking about
replace hydrogen. Yeah.
to
To
produce hydrogen,
dissociate the
right?
hydrogen atoms. Yes.
If something is giving H positive, then it is going to act as a acid.
I said yes.
If I'm talking about HCl, how many H positive I am producing? One.
One.
But yes.
If I'm talking about H2SO4,
Yes.
I am producing two hydrogens, two H positive, right?
Yes.
So for this acidic reaction of HCl, the N value is going to be 1. For H2SO4, it is going to be 2. So this N factor will vary from reaction to reaction. For acidic reaction, we will deal in terms of H positive, how many H positives are getting produced. Okay. For
Okay.
HCl,
It
the N
depends on
factor
how
is 1.
many H positives are getting into water.
Produced for acidic reaction,
Okay.
right? But if you are
Okay.
talking about a basic reaction, in basic reaction, it will deal in terms of NaOH. Suppose, sorry, OH negative. The purpose of a base is to produce OH negative, right?
Yes.
If I'm taking NaOH, it is producing how many OH negative?
One.
So for this, you have N factor 1. If you are talking about Ca, OH twice, it is producing 2 OH negative. So the N is 2. So for different reaction, the N factor is different. For acidic, it will talk in terms of H positive that are getting produced. For base, it will talk in terms of OH negative that are getting produced. Is it clear?
Yes.
Okay, so let us use this in a question. See, this is a question. They are asking you about what? They are asking you about the given mass. How many gram of dibasic acid? Dibasic acid means a acid which is producing 2 H positive.
Okay.
A diabasic acid is which is producing 2 H positive. If something is producing 2 H positive, then N factor is going to be
2.
2. Kamran, is it making sense? Abdullah?
Yes.
Any doubt, then let me know. Dibasic acid means that you are producing 2 H positive. So the N factor is 2. Okay.
Okay. Yes.
The molar weight they have given you is 200 gram.
Yes.
The volume is 100 ml. Okay. And
Yes.
the normality is also given. What they are asking you about the given mass. So if you see the formula for normality, given mass upon molar mass into volume into N. They have given you normality, they have given you N factor, they have given you molar mass, they have given you volume. They are asking you about.
Given mass.
So you will
Given.
keep given mass at one side and you will send the rest on the other end. Okay.
Others.
You know the normality, which is 0.1.
Yes.
You know what? See, you know the volume, which is
Yes.
in 100 ml. So
100 ml.
first you need to convert it into
Uh,
liter, because
liter.
molarity
So
we use in
zero
liter.
point 0.1 ml. 0.1 liter.
0.1 ml, right?
Yes.
Yes.
We
Yes.
have to convert ml into liter. So
Yes.
the rest is also given. 200 molar mass is given, right?
Yes.
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 So you just have to put the
And
values
so
and you get
So
the answer,
for
which is
finding normality, basically this is the formula. Gm into n by m into n. Yes.
okay.
Yes.
Basically, normality is what? Normality is nothing but molarity into n.
Mhm.
If you know the formula for molarity, you can simply identify or calculate the normality as well. You just have to multiply it by n factor.
Okay. 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 Okay.
okay.
Any doubts?
No.
No.
By the way, we have our exams from Jan first week pre-board. So by the
Yeah.
time, how many chapters could we complete out of this
See,
syllabus?
by the next class now, we will complete this chapter and we might be able to start the next one as well, right?
Yes.
So, what I can tell is, suppose how many chapters like complete syllabus will be coming, right?
Yeah, complete syllabus is
Yes.
coming.
In January, we have November, December. Okay, we will be able to cover what? The first book and the redox. Redox is in first book or second book?
Second book.
Second
Second
book.
book.
We can, like, for sure we can cover till redox, and the
Okay.
rest rest chapters. How many chapters are left? The
I think
I
hydrocarbons.
think
already
so. Two is left, no?
Two is
Organic and
left.
hydrocarbons.
So we will try to cover it all, but for that you need to work hard as well, right?
Yeah.
Whatever I'm teaching, just revise it as we
Okay.
are going ahead. Okay,
Okay.
so we
Okay.
will be able to cover it, inshallah.
Okay.
So this next topic is, let me just give you a brief. Okay, we
Yeah.
will cover it in detail in the next class, and what I would suggest you to go through it. The empirical formula and molecular formula is nothing but following step. You just have to follow step and you will get your answer. This is a sort of memorization part. You have to understand the steps. First step, second step, third step, fourth step. What empirical and molecular formula basically means, let me tell you about that. Suppose if I'm taking this glucose formula, this is glucose, right?
Yes.
yes.
This is a molecular formula. This is the formula for glucose, the molecular formula. In molecular formula, you are seeing the exact number of atoms. In
Mhm.
glucose, you have 6 carbon, 12 hydrogen, and 6 oxygen atoms, right?
Yes.
But if you are converting this into empirical formula, you are using simplest whole number. Suppose you have 6
Mm.
carbon, 12 oxygen, no, sorry, 6 carbon, 12 hydrogen, and 6.
6
If you
oxygens.
are, if you have to convert it into simplest whole number, then you can do
Yes.
what? You can just simply divide it by 6. You will get 1 to 1.
Yes.
If you are writing your formula in simplest whole number ratio, then you will call it empirical formula.
Okay.
Your
Mm.
molecular formula is the formula where you are actually seeing the number of atoms, how many number of atoms are actually present in your molecule. But if you're talking in terms of empirical formula, you are just taking the simplest whole number ratio of those atoms.
Okay.
This is your empirical and molecular formula simple definition. In the next class, we will understand how we can calculate
Today
or
also
solve.
1 hour class.
I think from the next class, it will be 1.5 hours.
Okay.
Okay.
Okay, so this is it for today's class.
Yeah. Thank you very
Yes.
much.
You have this PDF, right?
Yeah.
So,
Yeah. I.
Yes. PDF. Yes.
or what I want you to do is do the NCRT questions.
Okay.
Yeah, that's it for today's
Okay.
class. We will meet in the next one. Bye bye.
Okay.
Okay.
Bye.
Thank you.
Thank you.
Say good night. You can say good night as well.
Yeah, bye. Yeah, good night.